The sum of two squares has two factors which are both imaginary numbers, and the difference of two squares has two factors which are both real numbers. So let's say we had two perfect squares, x squared and a squared, and we had the sum of these two squares. If you factor this polynomial, you would get x plus ai, the imaginary term, times x minus ai. And if the sum of the two squares is equal to 0, then you would find the values of x by setting each factor equal to 0 and solving for x. And that would show you that x has a value of negative ai, an imaginary term, and x is equal to positive ai, another imaginary term. Let's take a look at the sum of two squares using real numbers so that this can create a little bit more clarity. Let's say we were given x minus 2i times x plus 2i. If you were to FOIL this out, you would get x times x, which is x squared, x times positive 2i, which is positive 2xi. Negative 2i times x is negative 2xi, so these will cancel out. Negative 2i times positive 2i gives you negative 4i squared. So once these cancel out, we want to replace I squared with negative 1. Negative 4 times negative 1 gives you positive 4. So we see that these are the factors for the sum of two perfect squares. Now, because the sum of two perfect squares leads to roots that are imaginary, we will not be covering the sum of two squares in this chapter. To review the sum of two squares, click on the link at the top of the screen or in the comment section, and that will direct you to our chapter on complex numbers. Okay, for this chapter, we are going to focus on the difference of two squares. So let's say instead of addition, we had subtraction, and we had x squared minus a squared. If you were to factor this, you would get x plus a times x minus a. So if you set each factor equal to 0 and solve for x, we would see that x is equal to negative a real number, and x is equal to positive a real number. But let's take a look at this with real numbers so that we can gain a little bit of clarity. Let's say we had x plus 2 times x minus 2. If we FOIL this out, we would get x times x, which is x squared. X times negative 2 gives us negative 2x. Positive 2 times x gives us positive 2x. So these two terms will cancel each other out since they equal 0 together. And positive 2 times negative 2 is negative 4. And when these two terms cancel out, we are left with x squared minus 4. So we see the difference of two squares will lead to factors that have real numbers. So we see that for the difference of two perfect squares, we wind up with factors which are both real numbers. Now let's take this concept of the difference of two squares a bit further and discuss the coefficient. The coefficient of the quadratic term must be a perfect square, and the square root will be the coefficient of x in each factor. So you can factor the difference of two squares even if the coefficient of the quadratic term is not equal to 1. In this case, it's 4. So when we find the square root of this term, we would get the square root of 4, which is 2, and the square root of x squared, which is x. So 2x winds up being the first term in each factor. So when you are factoring the difference of two squares, consider the coefficient, and you find the square root of the coefficient the same way you would x squared, and that would be the first term inside each factor. Let's take a look at another example. Let's say we had 9x squared minus a squared. We take the square root of the first term. The square root of 9 is 3. The square root of x squared is x. So 3x is the first term in each factor. We have a plus in one factor, a minus in the other. Remember, these signs will be opposite. And the second term in each factor is equal to the square root of the second term in our polynomial. So the square root of a squared is a. So we see when we factor 9x squared minus a squared, we would get 3x plus a times 3x minus a. So the coefficient of the quadratic term is one thing to keep in mind. Another thing you should keep in mind, there are some situations you'll need to remove a factor first in order to create the difference of two perfect squares. So a common factor can be removed from each term to convert the polynomial into two perfect squares. So here we have 18x squared minus 8. 18 is not a perfect square. 8 is not a perfect square. But 9 is, and so is 4. So that lets us know that if we can cut each of these in half, we would get the difference of two perfect squares. So we want to remove 2 from each of these terms. 18 divided by 2 would give us 9, x squared, minus 8 divided by 2, which would be minus 4. Once we remove that factor, now we have the difference of two squares. And we would proceed, just as we did previously, by breaking this up into two factors. So again, keep the coefficient of the quadratic term in mind, and also keep in mind that you may have to remove a factor from the polynomial in order to create the difference of two perfect squares. Now let's go through factoring the difference of two squares step by step. Let's say you were asked to factor and check the answer for 4x squared minus 16. So we have the difference of two perfect squares. Step 1, create two sets of parentheses. Step 2, place a positive sign in one factor and a negative sign in the other factor. And now the third step, add the square root of the first term to the left side of each factor. So the first term we have is 4x squared. The square root of 4 is 2. The square root of x squared is x. So 2x is the first term in each factor. We put that on the left side of each factor. And now we take a look at the second term. The square root of 16 is 4. So we'll add the square root of the second term to the right side of each factor. So our final answer is the factors of 4x squared minus 16 are 2x plus 4 and 2x minus 4. And now we can check this answer by multiplying the factors. The final polynomial should be the original polynomial. That would confirm that these are in fact the factors. 2x times 2x gives us 4x squared. 2x times negative 4 is negative 8x. Positive 4 times 2x is positive 8x. Positive 8x and negative 8x cancel each other out. And positive 4 times negative 4 is negative 16. So we see that the final polynomial matches the original polynomial, which confirms that 2x plus 4 times 2x minus 4 are the factors that will give you a product of 4x squared minus 16. So that is how you go about factoring the difference of two squares. Let's now have you complete a few practice questions. Question number 1, factor x squared minus 49 and check the answer. Question number 2, factor 9x squared minus 36 and check the answer. And question number 3, factor 32x squared minus 50 and check the answer. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we were given x squared minus 49. Step 1, create two sets of parentheses. This is where we'll place our factors. The next step, we want to place a positive sign in one factor and a negative sign in the other factor. And now step 3, we want to add the square root of the first term to the left side of each factor. The first term is x squared. The square root of x squared is x. So that's the first term in each factor on the left side. And now we look at the second term. The square root of 49 is 7. So we place the square root of the second term to the right side of each factor. So we see that when we factor x squared minus 49, we get x plus 7 times x minus 7. And now we can check the answer by multiplying the factors. the final polynomial should match the original polynomial. So we get x times x, which is x squared. Then we have x times -7, which is -7x. Then we move on to the next term and we get 7 times x, which is +7x. These two terms cancel out, and we have 7 times -7, which is -49. So since the final polynomial matches the original polynomial, that confirms that x plus 7 and x minus 7 are the factors of x squared minus 49. Question number 2. We were given 9x squared minus 36. Step 1, create two sets of parentheses for our factors. Step 2, place a positive sign in one factor and a negative sign in the other factor. Then we want to move on to evaluating the terms of the polynomial. So step 3, add the square root of the first term to the left side of each factor. The square root of 9 is 3. The square root of x squared is x. So 3x is on the left side of each factor. Step 4, add the square root of the second term to the right side of each factor. The square root of 36 is 6. So we add 6 to both factors. And we see that when we factor 9x squared minus 36, we get 3x plus 6 times 3x minus 6. And now to check the answer, we want to multiply the factors to make sure that we get 9x squared minus 36 when we do so. So we get 3x times 3x, which is 9x squared. We get 3x times -6, which is -18x. 6 times 3x is +18x. These two terms cancel each other out. And lastly, we have 6 times -6, which is -36. So since the final polynomial matches the original polynomial, that confirms that 9x squared minus 36 is equal to 3x plus 6 times 3x minus 6. And now question number 3. We were given 32x squared minus 50. We'll notice that 32 is not a perfect square and neither is 50. But if we were to cut each one of these in half, we would get 16 and 25. So that's the clue that we need to let us know that we want to remove a common factor from each term, which in this case is 2. 2 times 16 would give you 32. 2 times 25 would give you 50. So once we remove the common factor 2, we are left with 16x squared minus 25, and that is the difference of two squares. So now we can proceed with the normal steps. So step 2, create two sets of parentheses so that we can factor this part of our expression. And now step 3, place a positive sign in one factor and a negative sign in the other factor. And now we take a look at the first term inside the parentheses here, 16x squared. And we want to add the square root of the first term to the left side of each factor. The square root of 16 is 4, and the square root of x squared is x. So 4x is on the left side of each factor. The square root of 25 is 5. So we add the square root of the second term to the right side of each factor. And once we've done so, we see that 32x squared minus 50 is equal to 2 times 4x plus 5 times 4x minus 5. And now to check the answer, we want to multiply the factors. So we'll start by multiplying the expressions inside the parentheses. 4x times 4x is 16x squared. 4x times -5 is -20x. 5 times 4x is +20x. Those will cancel each other out. And +5 times -5 is -25. And once we distribute the 2 to each of these terms, 2 times 16 would give us 32x squared. And 2 times -25 would give us -50. So since the final polynomial matches the original polynomial, that confirms that we found the factors which are 2, 4x plus 5, and 4x minus 5.